Hello. Today, I want to share an interesting story about how advanced technology impacts our daily lives, especially in the workplace. Recently, our company implemented a state-of-the-art AI-based facility management system. This system monitors complex factory equipment in real time, predicting potential failures in advance, truly embodying future technology. Beyond just showing current equipment status, AI's ability to learn from past data and autonomously analyze future anomalies is expected to change equipment management paradigms. Everyone felt a mix of anticipation for this new system and concerns about the unknown. Longtime experienced employees felt both curiosity and anxiety about whether their experience and intuition would be replaced or enhanced by AI. When the sales team representative passionately explained the system's advantages, employees showed both curiosity and doubt, wondering, is that really possible? It was clear there were conflicting feelings about its applicability in our field. Now AI even informs us of malfunctions in advance. And it's about malfunctions before we were born. In that cry, we sensed a new era beginning. Veterans on site, though skeptical, listened closely to AI's promises of improved work efficiency and enhanced safety. Today's video vividly captures the tumultuous episodes that began on the very first day. Smart maintenance technology was introduced. Has AI truly met our expectations perfectly? Or has it brought unexpected chaos and unpredictable situations? Let's begin that exciting story now. Let's experience together the winds of change the new system brought, along with the delightful and significant events that unfolded. I hope this story resonates with you and piques your interest. The first week after system installation was truly a series of ups and downs. A chaotic time that shattered the calm. Every morning, alarms blared loudly. From various places in the office and on site, each alarm sounded like an emergency warning, making employees' hearts race. In fact, with alarms ringing, even during break and lunch times, employees found it difficult to rest. Boiler room pump abnormal vibration detected, server room temperature rising, signs of motor overload on the production line, compressor hydraulic pressure drop. Warning, normally quiet equipment was now emitting warnings, like hospital ICU machines. Kim, the veteran from the facilities team, and his colleagues constantly chased these alarms. They would rush to a boiler room, finding vibration barely perceptible to humans, but unequivocally flagged by AI's hypersensitive sensors. Then, a dash to the server room, where temperature had crept up slightly, a change previously unnoticed until a component failed. AI's ability to predict failures 30 to 90 days in advance, as promised, was a marvel. It leveraged IoT sensors, continuously collecting data on vibration, temperature, pressure, and power consumption. These smarter, cheaper sensors, even attachable to older equipment, provided a deluge of information. Edge and cloud computing processed this data, feeding it into machine learning algorithms that detected subtle patterns indicating impending faults. These algorithms discerned intricate shifts in drive currents or motor vibrations, signaling problems weeks before breakdowns. The promise was clear: reduced downtime by 30 to 50%, a 10 to 30x ROI within 12 to 18 months, and an 18 to 25% reduction in maintenance costs. Improved machine life by 20 to 40%, and a 40% improvement in equipment uptime through digital twin integration were also touted. These benefits were not just theoretical. Similar AI systems prevented 5 weeks of downtime on a stamping press in automotive manufacturing, achieving ROI in under 3 months. Power generation companies saw $7.5 million in annual savings by enabling planned maintenance. Even Siemens and General Motors used AI to monitor machines and anticipate breakdowns. However, the first week painted a different picture for our team. The continuous stream of alerts, though accurate, felt overwhelming. AI was good at identifying anomalies, but these weren't always critical enough for immediate action. It was a learning curve, understanding the difference between urgent warnings and minor deviations. Initial high implementation costs, integrating with legacy systems like PLCs and SCADA. not designed for AI analytics, and data quality issues incomplete. Inconsistent or siloed data were significant barriers. Then there was the black box nature of some AI models. While providing predictions, understanding their reasoning was sometimes opaque, creating unease. The biggest challenge, perhaps, was cultural resistance and the skills gap. Kim's team, with decades of experience, diagnosed problems based on senses. Now, they were asked to trust an algorithm flagging microscopic changes. The data volume, while powerful, required new skills to interpret. There was a shortage of AI, machine learning, and data science expertise to fully harness the system's potential. Despite initial chaos, a glimmer of the promised future emerged. One afternoon, the system issued a critical alert for a motor, indicating impending bearing failure within 48 hours. This was accompanied by a clear data visualization, showing accelerating vibration and temperature. Kim, after initial skepticism, trusted the system and scheduled a preemptive shutdown. Upon inspection, bearings were indeed on the verge of catastrophic failure. Replacing them during a planned, brief shutdown saved what could have been days of unplanned downtime and significant costs. This incident was a turning point. It highlighted the system's ability to prevent costly disruptions, not just detect minor deviations. It demonstrated benefits moving from reactive to truly predictive maintenance. The experience proved AI was not a replacement for human expertise, but an augmentation. Veterans' intuition, combined with AI's insights, became more powerful. The initial chaos slowly gave way to a new order. Employees understood alarm nuances, distinguishing critical warnings from minor fluctuations. Training programs were initiated to bridge the skills gap, focusing on data interpretation and AI model understanding. The company also started pilot implementations, focusing on critical assets, establishing data pipelines, training models, and integrating with CMMS for automated work orders. Validation and optimization became continuous. The vision of a sensor-rich environment and a proactive maintenance culture took shape. Veteran skepticism transformed into cautious embrace. They saw how AI alleviated constant vigilance, allowing focus on strategic tasks. AI wasn't stealing jobs, it was elevating them. The loud alarms of the first week became more refined, more intelligent. The factory, once prone to sudden breakdowns, moved towards anticipated, planned interventions. It was a journey of adaptation, a testament to human-technology collaboration for efficiency and safety. The initial chaos was simply the beginning of a new era of smart maintenance, where changes brought delightful and significant events to our field.